Hi again. So I need to clarify some things about the previous tutorial on how to do the delayed sliding system. And maybe I haven't been clear enough to specify some things, and maybe the results could have been different. So let's head back to the tutorial from scratch. In this case, I will not bring up Optimus Prime, but I created a kind of rig. In this case, it's the leg because it was the problem in there. So we have the thigh bone, which is, the thigh, the shin bone, which is the one that has the IK constraint that does the magic. Magic, it moves. So it basically moves in this way. And then we have the pole target, which basically makes the leg rotate in this way. And we have a root bone, which doesn't hurt anyone, so it doesn't matter. So now we also have the mechanical piece, so it's the bone that slides. So it was the mechanical piece you had on the leg on the longer haul model, I think, and it basically has the piece that needs to slide in this way, the y-axis, to actually cover some mechanical parts in those. And then we have the higher bone and the lower bone, which if I slide this down, then the other one gets dragged down with a few setups. So now, putting everything together, I'll show you again what to do. We start with the higher bone. The higher bone, in this case, these bones need to be in this exact way to have everything set up and work correctly. And also, all the bones need to be on the XYZ Euler rotation orientation, or the order, not quaternion, because I haven't specified this way. Maybe it could affect the way of behavior, and it would get different results, so it doesn't let it work. So you need to put XYZ Euler on all the bones. And I hope it doesn't break your rig, because maybe I don't think so, because it's just the order of the axis. So you put XYZ Euler on all the bones in this case, or just these types of bones that need to be slided, and this one too. So now let's get back to the higher bone. So we concentrate on these two. I'll actually highlight these two and that's it. So we have the higher bone that has two constraints, sorry. The first one needs to be the transformation constraint. The transformation constraint has the target, the armature, which is the whole armature here, the bone, which is the shin. This shin is this one, the one that has the rotation that has to do. And in this case, since this rotates in backwards, in this case, it will slide this bone. And as you can see, it does the magic here, as you can see. So let's concentrate on this bone, okay? So there is this leg that bends like this, which is the shin, and makes the bone slide. But before knowing what to do, we need to see where the rotation goes, whether it's positive or negative. I bet it's going to be positive, but if it's going to be negative, I'll show you what to do. So we go to R, we press R, and then X 2 times to actually have the local orientation of the rotation, in this case the X-axis. We rotate and we see the axis is positive, so we need to put the positive value. So we map from, also the target and owner both need to be on local space. And the influence needs to be at 1. We need to map from rotation, which is XYZ Euler, and the maximum needs to be 45, whatever number. So since this is positive, we put the positive value in the max settings. We cannot put positive value in the minimum. If it was negative, you put this value, which has to be negative, in here. But in this case, it's positive, so it needs to be in this way. Then we map to the location, in this case, taking only the x-axis, so we put x on all the 3 axis outputs. And in this case, we have the y-axis that needs to be affected. So it gets affected and goes to 1.5 meters once this is at maximum. So it would basically do this. it was slide down at the maximum. So the 45 degrees, as you can see, it reached the 45 degrees and it stopped. So it stops at that point. So this is the transformation constraint that needs to be done. Then you need to add a limit rotation constraint, which you need to check all the axes. You need to put the order as X, Y, Z, E Euler, affect the transformer. So you need to be check this in. And the owner needs to be local space, because if you put world space, it does this one. So it's not the original location. And if you deactivate it, it will basically snap it back to the original. So this needs to be this way, okay? Also, now let's go to the lower bow. It has 3 constraints. So these ones are not complicated, so only the transformation constraints are kind of complicated to do. We have a copy location constraint, which has the target, the armature. The bone is the higher bone. So this is the higher bone. And basically what we do is to only check this one, because if you have checked all the axes, remove these and just keep the z-axis, because it's the only one we need. But why the z-axis if it could be the y location on the local space? Because with copy location is kind of weird, does weird behaviors if you don't set it up correctly, but not because of bugs, but on how it's set up basically. You don't remove the offset and you put the target world space. And also these bones must not be parented to anything whatsoever, so these need to be floating here with anything attached, with nothing. Because if you attach something, then the behavior could be different and it would not project the correct result. So basically you need to put the world space on both target and owner in the copy location of the lower bone. Then we need to do a limit location. This case will be a different setup. In the limit location, you need to check all the minimum axes, so it has 0 on the higher one, so it doesn't move on the top. And also you need to check the x-axis and z-axis and remove this maximum here. So you need to keep this unchecked, so the y-axis can move without any problems. And you affect the transformer. And then the owner needs to be local space too, so to actually have the correct function. Because if you put world space, it will basically snap this item to the origin of the world. So you needed to put the local space to make this work. After doing the limit location, we go to the limit rotation. So you need to put the x, y, z axis. The order needs to be x, y, z, E Euler. You need to affect the transformer and put the local space. Same reason, because if you put world space, it will do this. It will not have the correct thing. You need to put the local space. And there we go. After setting this up, we head to this one, which is the bone piece, which is the mechanical piece that slides down. We need to put just a transformation constraint. But in this case, the target is the armature, the bone is the lower bone, which is this. The target needs to be local space, the owner needs to be local space, so both of these needs to be on local. We map from the location of the y-axis of this one, because this one is the bone that moves it. The map from is maps from this bone and maps to this bone. Okay, so we map from this, which the y-axis needs to be in this case in the positive one, because since it's facing down, it will be positive. But if the directions are switched, it will the positive side is up and the negative value is down. But if we switch back to the original one, the positive side is down, the negative side is up. So basically it's inverted. So we need to keep this in this way. So let's head back to this. So we map from the location, the positive value, whatever value you want to have. I recommend a big value if you want to slide more. And it depends even to the map too. So map to location in this case, and we only take the y-axis, which needs to be on all three, y, and y-axis. We map to location in this case, not rotation, and we put in the y-source axis in the maximum value, so to actually make it work, because since this is in the maximum, we put the map to in the maximum too. If this was negative here in the minimum, we would have put, even this, if this was positive, it would not create any weird behavior, we put it here. So there is no problem whatsoever. So we map to the location and we put the desired output when this reaches the maximum. So this is the final locations. And in fact, it would work. Now, if we use this bone and try to, oh no, let's take the IK bone, which is deactivated, to show the result. If we slide it in the local x-axis, that one slides down because it's affected by the sheen. Then once it reaches this, it will also slide down, so the lower bone will slide, so it will make the mechanical piece slide.